Welcome to Mathematics Online Lecture Series by Professor K. V. Narasimhan, Vector Calculus, Lecture number 24, Vector Integration, third lecture. So, today's problem based on line integrals. So, here we will discuss about the line integral problems. Now, what is the today's first question? Evaluate the line integral x square plus xy dx plus x square plus y square dy, where c is the square formed by the lines y equals to plus or minus 1 and x equals to plus or minus 1. Now, what is the solution? Okay. In this problem, f dot dr is directly given. Given that f dot dr equals to x square plus xy into dx plus x square plus y square into dy. Okay. This is directly given. Now, what is the diagram? Diagram is, curve is a square formed by four straight lines x equals to 1 and y equals to 1, x equals to minus 1 and z equals to minus 1. Okay. I will take a square diagram. Okay, I will show you with straight lines. This is x-axis and this is y-axis. Okay, listen. I will explain one by one. This is x-axis. This is x-axis. This is y-axis. Now, here x equals to 1. Here x equals to minus 1. Here y equals to minus 1. Here y equals to 1. So, the four straight line, this is a straight line x equals to 1 is a straight line parallel to y-axis, x equals to minus 1 is a straight line parallel to x-axis, y-axis, and y equals to 1 and y equals to minus 1 are also straight lines parallel to x-axis. Okay, now this is a triangle is given. Now, this is first point A, this is second point B, third point and fourth point. What is the common point? Here x coordinate is minus 1, here y coordinate is minus 1. Here x coordinate is 1, y coordinate is 1, minus 1. Here 1, 1. D, x is minus 1, y equals to 1. So, now angle is this one, anti-clockwise direction. So, now we will find the integral along AB, along BC, along CD and along DA. Finally, we will add, this is the origin. Finally, we will add the four integrals, then we will get the integral along the closed curve C. First, 1 along AB. Here what is A? Minus 1, minus 1. B equals to 1 comma minus 1. If you observe, x equals to initially minus 1, then it is 1. Okay. And also y Here minus 1, here also minus 1 at A and B, minus 1. Then what do you say? Dy equals to 0. If you substitute dy equals to 0 and y equals to minus 1 in f dot dr, then what happens? What is f dot dr? F dot dr, dy is 0, this entire term is 0, and y equals to minus 1. X square minus x into dx. Because dy equals to 0. Because dy is 0, y equals to minus 1. Now integrate. Integrate f dot dr along AB equals to integral x square minus x into dx. X limits minus 1 to 1. Integration x cubed by 3 minus x square by 2. Simple integration minus 1 to 1. Put x equals to 1 now, 1 by 3 minus 1 by 2. Minus, if you put x equals to minus 1, minus 1 by 3 minus 1 by 2. Here 1 by 2 cancel, so you will get 2 by 3. Along integral f dot dr along AB equals to 2 by 3. In the similar way, along BC. What is B? B equals to 1 comma minus 1. C equals to 1 comma 1. Okay, we will verify in the diagram. B equals to 1 comma minus 1, C is 1, 1. Okay. If you observe these 2 points along BC, BC is a straight line, along BC, x equals to 1. Now dx equals to 0. Now y varies from here initially minus 1, then 1, minus 1 to 1. Then what about f dot dr? From this one, f dot dr equals to, here dx is 0 and x is 1. Dx is 0, so this entire term is 0, x equals to 1. 1 plus y square, 1 plus y square dy. Okay, I will integrate. Integral f dot dr along BC equals to integral 1 plus y square dy. So y limits minus 1 to 1, already discussed. Now integration y plus y cube by 3. Now limits minus 1 to 1. If you put x equals to 1, 1 plus 1 by 3. If you put x equals to minus 1, minus 1, minus 1 by 3. So this is 4 by 3, here also 4 by 3, minus or minus plus, so 8 by 3. 3 plus 1, 4 by 3, plus 4 by 3, 8 by 3. So integral along BC equals to 8 by 3. Now third one. Along CD, where C equals to, straight line C equals to 1 comma 1, D equals to minus 1 comma 1. Now observe the straight line. Now observe this straight line. Along this straight line, now observe first point is 1, 1, last point is minus 1 comma 1. So if you observe this straight line, y coordinate is 1 and x varies from 1 to minus 1. X is x coordinate, x is 1 to minus 1 and y equals to 1. Now dy equals to 0. Now what about f dot dr? Now what is f dot dr? So dy is already 0 in f dot dr. In f dot dr, now see. Okay. In f dot dr, y equals to 1. So this is here x equals to y equals to 1, x square plus x dx. X square plus x dx. Now integration. Integral along CD. F dot dr. Integral x square plus x dx. So limits 1 to minus 1. Now x square integration is x cube by 3, x integration is x square by 2. Now limits 1 to minus 1. First put x equals to minus 1, so minus 1 by 3 plus 1 by 2. 1 by 3 plus 1 by 2. 1. Okay. Now fourth one. Along dA. D equals to minus 1 comma 1, A equals to minus 1 comma minus 1. Now check it. Similar problem is solved in vector complex integration. Okay, in complex integration, already we discussed in complex integration. So here my D is minus 1 to 1, minus 1, 1, minus 1, 1. Okay. If you observe the straight line, clearly x is minus 1, so dx equals to 0. Clearly. Now y varies from 1 to minus 1. So what is f dot dr? F dot dr. So dx is 0, first coefficient is 0. Just check it. Dx is 0 and x equals to minus 1, 1 plus y square dy. 1 plus y square dy. Now integration. Integral along dA equals to f dot dr equals to integral 1 plus y square dy 1 to minus 1. Integration is y plus y cube by 3, y cube by 3, limits 1 to minus 1. First put y equals to minus 1, minus 1 by 3. Now put y equals to 1, 1 plus 1 by 3. So this is minus 8 by 3. Now, what is the final conclusion? Therefore, integral f dot dr along the closed curve C, circulation C equals to integral along AB plus integral along BC plus integral along CD plus integral along DA. So inside is f dot dr is common. Dr is common. Now first value, now check it, first value 2 by 3, second value 8 by 3, minus 2 by 3, minus 8 by 3, 2 by 3, 8 by 3, minus 2 by 3, simple. Similar question is already discussed in complex integration, just to recall the concept. Now, seventh question is already discussed in our earlier video, integration along a triangle, already discussed. So here point is minus 1 comma 0, 1 comma 0, and this is 0 comma 1. Already we discussed this problem. Just I will show you the picture. Just find the straight line equations, and already we discussed in our earlier video. Now coming to next question. Solution. If A equals to 3x square plus 6y into I, now this is the second model in line integration. So first model is entirely some curve is given. In the second model points are given. In the third model the curve in parametric form. Okay. So in a vector is given instead of f, here a is given 3x square plus 6yi minus 14yzj plus 20xz square k. Evaluate integral a dot dr from the point 0, 0, 0 to 1, 1, 1 along the path. This path is in parametric form. Okay. Now, we know that r bar equals to xi plus yj plus zk. dr bar equals to dxi plus dyj plus dzk. Okay. What is f dot dr? Sorry, here a dot dr. 3x square plus 6y into dx minus 14yz. Okay, fine. Now, what is the given curve? The given curve in given x equals to in parametric form, y equals to t square, z equals to t cube. Okay, now what about dx value? Dx equals to dt, dy equals to 2t dt, and dz equals to 3t square dt. Okay. Now substitute all these values in f dot a dot dr. Substituting the above results in a dot dr. Then what you do? Then we get what happened. Okay. A dot dr equals to 3 into x square is t square plus 6 into y is also t square, dx is dt minus 14 into y, y is t square, z is t cube, dy is 2t dt plus, I will write here 20 x is t and z square is t power 6 t cube whole square, dz equals to 3t square dt. Just substitute all these results in a dot dr. 20 x into t power 6 into 3t square dt. Here minus 14, y is t square, z is t cube, dy equals to 2t dt. Now simplify. Simplification is very easy. So entirely the term is transformed into only one variable, single variable in terms of t. Now 28 t power 5 into t power 6 plus 60 t7 t9 into dt. Now this is a dot dr. Integral a dot dr along the curve c equals to 9t square 28 t power 6 plus 60 t power 9 dt. Now what about the limits of t? If you observe x is t, whenever x is t, limits of x are same as t. What about the limits of x? Here x coordinate is 0 to 1. So since x equals to t, so t limits are also 0 to 1. Or you may substitute in y limits or substitute in z limit, you will get the same thing. T equals to 0 to 1. Now integration is 9t cube by 3, 28 t power 7 by 7 plus 60 t power 10 by 10. Now limits are 0 to 1. Put t equals to 1. This is 3, this is 4 plus 6 minus, if you put t equals to 0, entirely 0. So this is 9 minus 4 is integral, hence A dot dr along C equals to 25 only. Very simple question. In the similar way, so I will give another question. Using line integral, compute work done by the force vector is given when it moves a particle from the point 0, 0, 0 to 2, 1, 1 along the curve x equals to 2t square, y equals to t, z equals to t cube. So in this situation, y equals to t, y limits 0 to 1, so t limits are 0 to 1. Suppose if you substitute x equals to 0, t becomes 0, x equals to 2, t becomes 1. Suppose if you put x equals to 0, z equals to 0, t becomes 0, z equals to 1, 1 equals to t cube, again t equals to 1. Limits, if you substitute any one of the equation, you will get the same limit 0 to 1. Okay. Now solution. So work done is nothing but integral f dot dr. Work done equals to integral f dot dr. Okay. R bar is already known, dr bar is also known. Directly I will write f dot dr. That is 2y plus 3 into dx plus xz into dy plus yz minus x into dz. But here r bar is xi plus yj plus zk and dr bar equals to dxi plus dyj plus dzk. F dot dr dot product is nothing but this one, already we discussed in the earlier problems. Here given that x equals to 2t square, y equals to t, z equals to t cube. Now dx equals to 4t dt, dy equals to dt, dz equals to 3t square dt. Now substitute all these results in f dot dr, then what happened? Now f dot dr equals to 2 into y equals to t plus 3 into dx is 4t dt plus x 2t square into z t cube, dy is dt plus y into z minus x 2t square dz 3t square dt. Now simplification, then integration. Here 8t square plus 12t, here 2t power 5, here t power 4 into 3t square plus 3t power 6 power 4 t square, okay, minus 6t power 4 dt. Okay, there is no repeated terms, then no problem. Integral f dot dr. Integral 8t square plus 12t plus 2t power 5 plus 3t power 6 minus 6 0 to 1. Now put t equals to 1 first. 8 by 3 plus 6 plus 1 by 3 plus 3 by 7 minus 6 by 5. So no other value is 0. So this is I will take simplification. 8 by 3 plus 1 by 3 is nothing but 3. 3 plus 6, 9 plus 3 by 7 minus 6 by 5. Now simplify, you will get the required solution. Okay, I will write the direct answer. using calculator or anything, just find out. 9 plus 3 by 7 minus 6 by 5. 9 plus 3 by 7 minus 6 by 5 is 288 by 35. Just verify the calculation part. Hence, integral f dot dr equals to 288 by 35. Just verify the answer. If there is any numerical error, now correct it. Now second problem, this is also similar question. So here in this problem, question is work done. So answer is also like this. Instead of this one, work done. Work done. Here also I will call it as work done. Total equals to this one. In this problem also, just find the work done from the point x. So from the point 0, 0, 0 to 1, 1, 1 along the curve. Here x equals to t means x limits are 0 to 1. Same procedure. Just find f dot dr. F dot dr is 3x square minus 6yz dx plus 2y 3xz dy plus 1 minus 4xyz square dz. And given that x equals to t, y is t square, z equals to t cube. Given that, now x equals to dx equals to dt, dy equals to 2t dt, dz equals to 3t square dt. Just substitute all these values, x value, y value, z value in f dot dr, and dx value, dy value, dz value. So you will get entirely in terms of some expression in terms of t. Just work done equals to integral f dot dr along the curve C. Nothing but integral this expression into dt. Now t limits already known. X equals to t, x limits 0 to 1, so t limits are also 0 to 1. Just calculate all these values and take it as homework. Homework. This is homework for you. Very simple. Just to solve it. Next question. Quite interesting. Just observe it. Just try it. Only try it. I will explain in the next class. Evaluate integral xy plus z square ds, where c is the helix, x equals to cos t, y equals to sin t, z equals to t, which joins the points 1, 0, 0, minus 1, 0, pi. This is quite interesting question. This is quite interesting question. So I will give a small clue to you. Xy plus z square ds is now multiply and divide with t. Now multiply and divide with t. What is ds? Already x value is known, y value is known, z value is also known. Just substitute all these values in terms of in this integral. Then what happens? X cos t, y sin t, z t square, ds by dt into dt. So t is also known, t limits, z equals to t, z limits are 0 to pi. But how to find ds by dt? Now this is very simple. I will explain in the next class. Just try it. Okay, we will discuss in the next class. Thank you. This is quite interesting and very easy. Okay, meet again. Bye.